All right, this lesson is about finding all the zeros and the factors of a polynomial that has degree 4.
Minus 15.
Okay, so if you type the equation into the table feature of your calculator, all right, then you can scroll around looking for 0 on the y side. Where did you find it? You found the first one you found? Yeah, there's two of them. There's one at -5 and one at -3. In the directions, though, I told you to use 1, 0, not 2. I want you specifically to use one of them and then do the rest of the problem by factoring. Okay? So if you use both zeros to do it, that's in general that's good, but that's not what I want you to do on this particular problem. So I'm going to use the -5. It doesn't really matter which one you pick, but just please only use one of them if I say just one. So if we use the -5, say, then the coefficients, so we have 4, 32, 59, -8, -15. Okay. Okay, so I've got 4, and that's -20, and that's 12, and that's -60, and that's -1, so that's 5, so -3, +15, and 0. Okay? Now, normally we would go back and use the other 0 that's on the calculator to do it again and go smaller, except I told you not to. So somehow you should be able to factor this polynomial from here. And that's what I wanted to practice with you on this problem. So if we put the variables back in here right now, hold on, let me just say this one thing. So we got this -3 has got to be the constant, okay? And then that means this is the x, this is the x squared, and this is the x to the 3rd power. So that gives us the polynomial 4x to the 3rd power plus 12x squared minus x minus 3. Okay, don't forget about the first 0 that we found. This comes down as a factor of x plus 5. And now we've got this polynomial, this purple one, that needs to still be factored. The only way I've taught you to directly factor a polynomial with 4 terms is grouping. All right, so let me remind you about how grouping works. Grouping was like this. You would take like the first 2 terms and the second 2 terms and factor out a GCF from each one of these. So looking at the first 2 terms, what's the greatest common factor between these two? 4x squared is the GCF. Any questions about how I'm getting 4x squared as the GCF? Okay. And then you go ahead and put inside the parentheses whatever you would get if you divided by 4x squared. What would I get on the inside?
We get x plus 5.
I would get x plus what?
X plus
3.
3.
X plus 3. Okay. Okay, on the other set, we need to pull out a GCF, but we need to treat this as a 1, okay, a -1. So let's pull this -1 outside of parentheses. And then, so inside the parentheses, we will have x plus 3 again. Any questions where I'm getting the x plus 3 from? Okay. Charles, is this making sense so far? Okay. Now, it's important for grouping, I needed both of these parentheses to be the same thing. All right? If it's the same thing, then I can pull it out front. I can factor out x plus 3 as a greatest common factor of its own. So I pull the x plus 3 away out front. That's going to leave behind the purple stuff. That's going to leave behind 4x squared minus 1. Okay, so far I've factored it down here. Now, if this were plus, if this were 4x squared plus 1, I'd have to stop. But because it's 4x squared minus 1, this is the difference of two squares, and we know how to factor this. How does 4x squared minus 1 factor down, you guys?
2x minus 1 plus.
Exactly. 2x plus 1, 2x minus 1. Okay? And of course, we'll bring down the x plus 3 as well. So now this is completely factored. And the zeros will be -3, -1/2, and +1/2. Okay? Of course, I'm getting those by setting, for example, 2x plus 1 equal to 0. And solving. Okay, so for example, that's how I'm getting these. Any questions on problem number 1? Yeah, I almost forgot. Don't forget to bring down the factor that we got from the calculator. All right, from the calculator we had the -5. That gave us a factor of x plus 5. That's still here. All right, I almost forgot to bring that down. Okay? And I shouldn't forget, because look at the degree. The degree is 4, so I'm looking to have 4 zeros. And I should have 4 factors. Okay? So if I left off the blue one, I only had 3 zeros, only had 3 factors. So I should have known that something was missing. So this is the complete answer. Okay? Of course, you would record it. I don't feel like recopying it, but you should put it here. All right, now for problem number 3. The directions have changed. So on the previous problems, I said just use 1 0 and then start factoring. So that meant I wanted you to do grouping, okay, to the second time around. But this time I'm saying go ahead and use 2 zeros. So I want to make sure that everybody's comfortable with how you use 2 zeros in a row, okay? So let's just type this into our calculator. I mean, you already did it, but now I'm going to do it. Can somebody read me? All right, so we've typed this into the calculator. Move this down a little bit. So I usually start at -10 because it rarely goes past -10. So I usually start from -10. And then I scroll down from there, looking for zeros on the y side. So the first 0 I come to is -4. So I'm going to use that one first. Okay, so I do my 0 of -4. All right, and I've got 6, -13, -144, 28, and 48. Okay, so that's going to be -24, so that's -37. What's 4 times 37?
4 times 37 is
148.
148. So that gives me 4. So that's -16. So that's 12. And so that's -48. Okay? Now, this time, grouping would not have worked anyway. Okay? So this is what you do. I think you were asking me, so this is what you do when grouping doesn't work, and yet we have to get lower. We find another 0 to use. So I'm going to scroll down some more. Boom, there it is. So there's another 0 at 6, so I'm going to use this 0 as well. So let me switch colors. Okay, so the way you use another 0 is you just put the new 0 next to the bottom row, and just like that, it becomes the top row. And then you just continue. So I'll bring down that 6, and so that's 36. So that's -1, so that's -6, so that's -2. So that's negative 12. And so there it works again. Once you get down to three numbers, a trinomial, you can, you're always good. You don't have to go any further than that. We can either factor it or complete the square or use the quadratic formula. There's always something we can do once it gets down to three numbers. Okay, so let's see what we've got so far. Let's not forget to bring down the factors from the zeros from the calculator. So negative 4 gives me a factor of x plus 4. Okay. The 6 gives me a factor of what? X minus 6. And now this trinomial, what's my trinomial?
It's 3x minus 2, 2x.
It's gonna be
6x squared.
minus x
I already did.
minus 2.
Right, 6x squared minus x minus 2. Okay?
No, I already did.
All right.
I already did that.
No.
Oh.
Yeah, I don't know what that reducing would mean in this context. Anybody lost so far? Okay, now this purple trinomial is probably further factorable. So let's try. So I'm going to take this purple trinomial and try to binomial times a binomial it.
That's what I did.
Okay, so okay. 6x squared. Matt, you were telling me how this factors down?
Yeah. Tell me
I just didn't know what you're talking about.
I reduced.
Just how does it factor?
I had 3x minus 2. 2x plus 1.
Okay, that's called factoring, not reducing. Okay, so all right. So this factors as 3x minus 2 times 2x plus 1. Any questions on how to factor that? Anybody need me to re-explain factoring? Okay, and then of course I'll just bring down the other two factors. So I'll have my x plus 4, bring that down, and my x minus 6. So these are my factors, completely factored. So that's what you should have had for your factors. And then of course my zeros are going to be negative 4, positive 6, positive 2/3, and negative 1/2. Okay, these are my zeros. And again, like for example, the way I'm getting these is I'm setting the factors equal to 0. So for example, if I set 3x minus 2 equal to 0, and I'm adding 2 to both sides, so I get 3x equals 2, and I divide by 3. Okay, so for example, that's how I got 2/3. All right, and that's how I would do them all. Any questions about number 4? Okay. This is number 5. Is this number 5?
It's number 4.
Oh, this is number 4.
Yeah.
Okay, that was number 3. Yeah, the 4 jumped. Okay, so this is problem number 4. So I think this is sort of the same as the last one. If you type this into your calculator, what zeros did you find off your calculator?
2 and 4.
All right, because I don't feel like typing it in. So I hear you saying that negative 2 and 4 worked. Okay, so let me see how fast I can do this. Okay, so starting with the negative 2. So I've got 4, negative 21, negative 18, 128, and 96. Okay, if I bring down the 4, that's negative 8. It's negative 29. What's 2 times 29?
2 times 29 is
58.
58. Okay, so that's 40, 30.
No, it's 40.
40, yeah, can't add. Okay, so that's negative 80.
Yeah.
So what's that?
48.
Okay, so that's negative 96.
Yeah.
So there you go. All right, and now we're going to go ahead and do the other 0 that you would find from your calculator is 4. Okay, so here we go. All right, so that's 16, and that's negative 13, and that's negative 52, and that's negative 12, negative 48. Okay, once we get down to 3, we can either factor it, or worst case scenario, we can use the quadratic formula. Hopefully I won't have to do that. Okay, let's not forget about the factors from the calculator. So we have our negative 2, and that gives us a factor of x plus 2. All right, we have our 4, and that gives us a factor of x minus 4. And then we have our trinomial here, which is 4x squared minus 13x minus 12. Did this factor? Let's try it. So 4x squared, the first thing I would try is 2x times 2x. Okay, then I would look at the 12. And looking at the 12, I'm thinking, all right, it's either 3 times 4, or 2 times 6, or 1 times 12.
It won't work.
Yeah, none of those would work with these 2's because no matter what I do, I'm going to have a GCF. For example, if I do 3 times 4, there's a GCF right there, okay? All of these pairs have even numbers in them, so they will all make a GCF. So that tells me that I can't do 2 times 2. So, well, no. First, I'm going to try 4x times x. I'm going to try that first. Okay, now I have options. So for example, now if I look at the 3 times 4, if I do 3 and 4 here, no GCF. So I have a shot at it. Okay. Now, inner plus outer equals middle, as you know. Inner, I have 3x. Outer, I have 16x. Is there any way I could get negative 13 out of these two?
Yeah.
What would the signs need to be? Somebody said plus minus. If I have a positive 3x and a negative 16x, that will give me a negative 13x. So this is looking pretty good. So positive 3 here, negative 4 there to give me the negative 16. One more thing. Does that give me negative 12?
Yes.
Sure. Positive 3 times negative 4 is negative 12, so that's good. Okay, so bringing down what we had before, we have x plus 2, and we have x minus 4. Now, as far as the factors, we have all of this, okay? You can either write it this way, with all 4 written separately, or if you wanted to, you could write, see how we have x minus 4 twice? If you wanted to, you could put, you could leave this one off and put x minus 4 squared, okay? You definitely can't just erase it. Either write it twice or write it once squared. Those are your options on that, okay? Okay, now for the zeros, so I'm going to have my negative 2 here, and I'm going to have a positive 4 from this guy, and I'm going to have negative 3 over 4. Now listen carefully. No, you do not list the zeros more than once, okay? Because this is just a list of solutions. So we wouldn't list it more than once. What I would like you to do is put some indication that you know that this is a double root, okay? And you could literally do what I just did. Put a little arrow and just write the word double next to it. That way, you know how the fundamental theorem of algebra, if you have degree 4, we're looking for 4 zeros. That way, the extra zero is not getting lost. We see that we have our 3 zeros, but this one's a double, so it counts twice. So we see we have our 4 that way. Okay, now if you forget to write the word double, am I going to take off? No, this is not one of the things I'm going to take off for. Okay, but if you think of it, I'll think warm thoughts about you if you put double to show me that you know. I'll be like, oh, that kid, that's a good egg right there. All right? Yeah, that's an old people expression. All right, any questions about that one? Real quick, looking at number 5, no synthetic. There should be no synthetic. This one you're supposed to do without using a calculator at all. See how it's a trinomial? Just factor it. Just straight up binomial times a binomial immediately. X to the 4th power. Guess how I'm going to factor that?
X squared.
X squared times x squared. Now that 8, it's either 2 times 4 or 1 times 8. Let's do the 2 times 4. Okay? Inner, I have 2x squared. Outer, I have 4x squared. So I need a negative 2 and a positive 4. Okay, so boom. Guess what? I just factored it completely. Neither one of these two factors can factor any further. So that is completely factored. For the zeros, what am I going to do? Right, I'm going to set each one of these equal to 0.
Wait, negative 2 doesn't reduce?
No, because that's not a perfect square. And say factor. Reducing is for like if you have 4 over 12, that's 1/3. That's reducing. Okay? So here, this would give me x squared equals 2. And then I'd have to take the square root of both sides. Don't forget your plus or minus. So that gives me plus or minus radical 2. This one, subtracting that 4 from both sides, I get x squared equals negative 4. Then I'd have to take the square root. Okay, don't forget your plus or minus. So that's going to be plus or minus 2i. All right, it's a negative under there. That's an I. So my 4 zeros are radical 2, negative radical 2, 2i, and negative 2i. All right, it's time to pack up. Okay, notice we didn't do any synthetic division on that at all.